Alright, let's say that we wanted to use a multiplexer or a decoder to implement a function. And let's say our function f of a, b, c, d is the sum of min terms 0, 2, 5, 8, 10, 12, 15. Alright, and first I want to do this with an 8-to-1 multiplexer. Well, after trying various different things, I think the easiest way to do this is with a truth table. Alright, so let me put another column in here. So I have A, B, C. Oh, I need yet another column. D, F, min term 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You know, when they make truth tables in logic, they start with true instead of false, and it just messes me up. Okay, so this is our function, and it has a value of 1 for min term 0, 2, 5, 8. So 0, 2, 5, one of these to be 1s. 0, 2, 5, 8, 10, 12, and 15. Okay, so now I'm going to look at these in terms of the first three variables. So when ABC is 0, 0, 0, so when ABC equals 0, so if I do every other row here, and I look at the value just of ABC at 0, 0, 0, when ABC equals 0, 0, 0, F equals the complement of D, because when D is 0, F is 1, when D is 1, F is 0. The same is true when ABC is 1, and when ABC is 2, F equals D. When ABC is 3, F is 0. When ABC is 4, it's the complement of D. When ABC is 5, it's the complement of D. When ABC is 6, it's the complement of D. When ABC is 7, it's D. And so now I can make a multiplexer . And my inputs are A, B, C. And I have for 0, 1, 4, 5, and 6, then when ABC is any of those numbers, then I want my output to be the complement of D. And for 2 and 7, I want it to be D. And for 3, I want it to be 0. Okay, so that's how I would do a multiplexer. Now, how would I do a decoder? Okay, so what a decoder does is it takes your binary number, so maybe a 3-bit binary number, and what it does is it takes your number and then it evaluates its value in binary, and then it outputs a 1 for the place value that your number evaluates to. So like for instance, if your number is 0, it'll have a 1 in the 0 position and zeros everywhere else. If it's 1, it has a 1 in the first position and zeros everywhere else. And so if I look at my decoder, so I would have if my number over here were 101, which is 5, then I would have a 1 here and zeros everywhere else. So that's how the decoder works. So how am I going to make that work with my function? Let's see, what was my function? Here it is. So 0, 2, 5, 8, 10, 12, and 15. But I only have a 3-bit encoder. So let's see. Let's take a look at these numbers. The numbers are okay, so if my numbers are A, B, C, D, if B, C, D is 0, then it doesn't matter what A is. This should evaluate to be 1. So I can have my answer. So if I have my input to A, B, C. If those evaluate to 0, oh wait, I had that to be B, C, D. Hold on. So I did, this is A, B, C, D. So if I have B, C, D, if those evaluate to be 0, then I know that my function is 1. Similarly, 0, 1, 0, that shows up for both of those. So 2, that works. Now, if I have 5, that is only going to be valid when A is also 0. So if I have 5 ANDed with not A, that one, and 4 or 7 ANDed with A. Well, not okay, so, and then the OR of those 4 things would be, would make my function with the decoder. So what I did was I looked at the last 3 numbers and saw what those last 3 digits made up, and then if it was true for the first digit being either 0 or 1, I could just put those right into my OR. But if it did not, then I needed to AND it with the appropriate value of A. And that should work.